Today's objective is continuing to be able to add and subtract polynomial expressions. So here, we want to simplify our expression that's given. Some of the tactics that we've talked about before is trying to group your like terms, and then you can work on the operation. So since we're adding here, we can take the elements and rewrite them and group those like terms together. And then form the operation. So we can see nothing is really matching with our first term. Our second and third terms are a match, so we're going to have 15a squared b squared. Our next two terms are a match, so we're going to have a negative 10a squared b, and then we have our constant of 5. And again, we said we'd write these in standard form, so we went with the highest degree for your variable for a, and variables are written in alphabetical order, and we want to write those terms in descending order for the exponents. That's why we've got a to the third b squared, a squared b squared, a squared b, and our constant. Let's try another one. Here we want to simplify this expression, and these two polynomials are being subtracted. So we have to remember subtracting means taking the opposite of what you're given to work with for that second expression. So if we take the opposite of what we're working with, now we can look at rearranging like terms together to combine them and simplify. So we do have some m squareds n's, and then we've got n squared m's, and then we just have two terms with no matches. So 6m squared n minus 3m squared n is going to be 3m squared n, negative 5mn squared, and then we've got our negative 6mn squared, that would be a negative 11, n squared m, and then we have our 2m and 8n. So I wrote this in descending order, alphabetical order for m's to n's. So I have 3m squared n minus 11m n squared plus 2m minus 8n. So adding and subtracting our polynomial functions can be done within context, within shapes, and other situations. So here we want to write a polynomial to represent the perimeter of the triangle. So we have to remember, what is perimeter? Perimeter means the distance around a figure. So if it's a triangle, it's the distance around the three sides. So we're going to have to add these three polynomials together. And as we add the polynomials together, we're going to look at trying to regroup those like terms and simplifying. So I've got some x squareds, x's, and constants to simplify. That means we've got 5x squared plus 7x minus 8, and since it's a perimeter, it's a unit of measurement, so we're just going to say units. That's the polynomial to represent the perimeter. Now, we are also said, well, if the triangle, x represents a length of 3 feet, find the perimeter of that triangle. Well, if we have the expression and x is 3, we could substitute that in and find how many units that is. So by substituting it in and following your order of operations, we would get 58 feet. Is a length of 3 feet a reasonable value for x in this triangle? So remember, not only do you want to look at the perimeter total, but we also want to look at the lengths of each of the sides that it came from. So if I substitute 3 in for x for each of the side lengths, we also want to double check and make sure, does that make sense? Well, what happens? If I take x and substitute 3 in for it, notice how this length right here would be 21 feet. This length here would be 49 feet, and this length here would be negative 12 feet. And you know a length cannot be negative, therefore it does not seem reasonable for this triangle. And again, the only way we would have caught this is by looking at the 3 individual lengths versus the total perimeter, because remember, that gave us a positive value. So in situations like this, where you have a polynomial representing a total, you still want to check the individual parts making it up to make sure it really seems reasonable for the entire situation. Let's take a look at this example. Here we want to find the perimeter of our shaded figure. And we have some lengths given to us. We know from here to here, that's 5p. Here to here, that's 3p plus 4. And this section from here to here is 6. So again, in purple, that's 5p, 6 is in blue, and 3p plus 4 is in green. Again, we want to find an expression to represent the perimeter of our shaded figure. So let's give you a moment to try writing that, and then we'll check. Based on these givens, we could match up some other equal lengths. 5p in purple is also at the base of our figure. And 6 repeats itself here on our figure. 3p plus 4 is from the 5p to 5p. So if I go to the other side of my figure, that would be represented as well. But notice how it's broken up into the 3 sections. It's still 3 plus 4. We just have the 3 parts in our picture. So we should be able to write the expression 2 5p's, 2 6's, and 2 3p's plus 4, making up the perimeter of our figure. So if we double each of those, right, following your order of operations, combine our like terms, we now have an expression of 16p plus 20 units for the perimeter of this figure. Here's another situation. The number f of fiction books in 10,000s and the number of n non-fiction books in 10,000s borrowed from a library can be modeled by the following. F equals 0.01t squared plus 0.08t plus 7, and n is equal to 0.004t squared plus 0.05t plus 5, where t is a number of years since 1995. Can you write an equation that models the total number of books borrowed from the library? Well, a library borrows all sorts of books, and this library was borrowing fiction books and nonfiction books. So the total would be represented by the sum of the two equations f and n. So if we add these two expressions together and try combining their like terms, that will tell us the total number of books. So if I reorganize my like terms, add them together, our total number of books borrowed would be modeled by 0.014t squared plus 0.13t plus 12. Here, the average cost I in dollars for a new imported car and the average cost D in dollars for a new domestic car can be modeled by the following two equations, I and D, where T is a number of years since 2000. Can you write an equation that models the difference in imported and domestic in an average car costs? So the key word here is difference. Difference means what operation in mathematics? Subtraction. For finding the difference in between imported and domestic, we need to subtract domestic from imported. That tells us our average car costs. So if I take the polynomial representing the imported and I take away the polynomial for domestic, that will give me the cost, the average car cost. So again, by subtracting, it's saying take everything opposite of what was in that second polynomial. Then regroup your like terms to simplify your polynomial expression. We should end up with the average car cost equation of negative 137.63t squared plus 2,263.06t plus 678. Now it's your turn to work on practicing adding and subtracting your polynomial expressions based on your givens, based on a figure, and based on a real-world scenario.